Um, okay, good evening, everybody. My name is Eleanor van Geuven. I'm Program Manager of the Dutch National Knowledge Center on Gifted Education. Tonight, our esteemed guest is Dr. Franzis Preckel, and she will take us on to a very interesting topic as the developmental perspective on giftedness, the talent development in achievement domains framework and its practical implications. Franzis, the floor is yours. Please feel free to introduce yourself and at the end of the session, we take some questions. I will make sure that you know where you are your last 10 and your last 5 minutes. There you go.
Okay. Yeah, good evening, everybody. Thank you, Eleanor, for having me in your webinar. I'm from Trier University. Actually, I grew up near the Dutch border and I understand a little Dutch, but unfortunately I can't speak it. At Trier University, I'm working in the Department of Psychology as a professor for giftedness research and education. And during the last years, we worked a lot on longitudinal data to better understand developmental processes from potential to achievement. We mainly work with students in elementary and secondary school, but I'm also interested in this long-term, lifelong perspective on talent development. And this is also the perspective with which I'm going to present today. And here's a short overview of the content. First, I'm going to summarize a few findings on giftedness, intelligence, and talent development to lay the ground for the TED framework as the model with which I work a lot. And I'm going to present some practical applications and also implications for identification and promotion and fostering in schools. So I'd like to start very basic. Giftedness is it's a challenging term, and there are many conceptualizations, but most of them agree that giftedness comprises a potential. It's not the same as high performance or achievement, but it's the potential to perform or to achieve. And therefore, we could also be more specific and say that giftedness is performance-related potential. And that's important because this concept is usually not applied to social relations. So you wouldn't speak of a gifted spouse or a gifted friend. It's related to achievement domains. So what do I mean with performance and achievement? It's not only reduced to outcomes. In English, there is this differentiation between performance and achievement. Performance is more related to the process, and achievement is the outcome. Interestingly, in German, we don't have this. It's the same expression for both. And I really like this differentiation in English. So you find performance and achievement here. And it is outcomes, but also being able to participate or to realize your own potential. So it's a very broad understanding of this term. And I think that's important. The traditional view of giftedness sees this potential as an inborn capacity. So this inborn capacity is there from the beginning and remains stable. So once you're gifted, you're always gifted. You can't somehow gain giftedness or lose it at one point in time. It's there forever. And it can be equated with high general intelligence. Frequently, you use cutoffs like IQ values of IQ 130 or 120. And this general intelligence is a broad capacity that enables you to achieve highly in many domains, not specific to one domain. It goes hand in hand with special learning needs, qualitatively different needs that require that gifted children are supported in specialized context. And the aim is to identify them very early and to provide appropriate support. And this traditional view has been named the gifted child paradigm, for example, in this paper by Diane Chen. And this paradigm received a lot of critique during the last decades. First of all, many people with high potential are overlooked if you equate potential with high general ability or intelligence, because there are other domains, other potentials. In addition, for some people, potential might show up later, for example, during adolescence, early adulthood, or even later, and these later bloomers would be overlooked. In addition, if you use general intelligence tests to identify giftedness in people, certain groups are underrepresented because there is no culture or context-free testing. These tests always measure the complex interaction of learning ability and the opportunities and contexts that somebody experienced up to this point. So this is always influencing test results. And there are divergent research findings. Before I present those, a short definition of what's meant with general cognitive ability or intelligence. I like this definition by Linda Gottfriedson a lot. I'll read it to you. It's a very general mental capacity that, among other things, involves the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. So it's a lot about learning and acquiring knowledge and skills. It's not merely book learning, a narrow skill, or test-taking smarts. Rather, it reflects a broader and deeper capability for comprehending our surroundings, catching on, making sense of things, or figuring out what to do. So I think this definition nicely depicts the benefits of being intelligent, because these things are needed in nearly every walk of life. So what do we know? How well can intelligence really predict or explain achievement? In the gifted child paradigm, it was the main factor. And from educational research, we know that differences in intelligence explain 25 to 50% of the differences in educational outcomes or school performance. This is pretty substantial, but it's not perfect. 50 to 75% are explained by other factors in the domain of personality or also environmental characteristics. Compared to other constructs, general intelligence is a pretty strong, maybe even the best predictor we know, but it's not perfect. Most variability is not explained by intelligence differences. And the gifted child paradigm also assumes that intelligence is stable, so it's there from the beginning. But we find in longitudinal studies that during elementary school, large changes are possible, up to 20 IQ points in both directions. And also in adults, up to the age of 45 years old, and nearly 50% of adults, you find changes in intelligence level up to 8 points on average. So we were interested in this question: how stable is intelligence with a lifetime perspective? And together with Moritz Breit and Sevolod Scherrer from my team and Alia Takadrop from the University of Texas at Austin, we conducted a meta-analysis of longitudinal studies that assess the stability of intelligence. And the findings that I present you are based on a sample of nearly 90,000 participants. So this is pretty good evidence. But before showing the results, first of all, I'd like to introduce our measurement. So it's a correlation coefficient between the rank order in intelligence tests at the first time of testing and at a follow-up second time of testing. In this example, you have 5 persons tested twice, and you see their rank order at the first time of testing, and it changes up to the second time of testing. And these changes in rank order can be statistically expressed in this correlation coefficient or the rank order stability. The maximum value is 1, and here you see a value of 0.71, which is already pretty stable, but you see that there are changes in rank order going on, so people change in positions. And what did we find for the longitudinal studies of intelligence? So on the x-axis, you find the age in years. And the rank order stabilities are depicted at the epsilon axis, and the dots, the purple dots, are effect sizes from different studies. And the black line, this exponential functions, depicts the changes in stability over lifetime. And you see that, yeah, starting from an age of around 20, it's pretty stable, does not change much anymore. And the stability is around 0.76. So this is actually pretty stable. And we all know that intelligence tests are not perfect measures, but they suffer from measurement error. But if you control for this, and if you treat the data as if they would measure perfectly, so you adjust for reliability issues, then you reach orange values, 0.86 on average. But even then, if you assess perfectly, it's never reaching 1. So there is some change going on. And especially in childhood, there's a lot of change going on. Stabilities are actually pretty low, below an age of 12. And this is not due to reliability, lower reliability in children. It's really the case that there's a lot of development going on. So what does this mean for applied test settings? Here you find different lines, and each line presents another group with another age at baseline. So the black line is for 2-year-olds, then the red line is for 4-year-olds, and so on. And on the epsilon axis, you see that the value of 0.8 is marked by this orange circle. Why is that? If we assume that in individual cases, we would at least need a stability of 0.8 to make predictions with the test results for the next month or years or so, then you see that this value is not reached before the age of 10. And what you also see is that with increasing test intervals, so a higher age at retest, especially for younger groups below the age of 10, the stability values decrease significantly. So that means that below 4 years of age, there isn't sufficient stability to make any predictions. Tests are absolutely valuable to assess 4-year-olds' cognitive ability at this point of measurement, but you cannot really use the test results to make any predictions. So when you think back of the gifted child paradigm, you can't say that this child, for example, who has a very high IQ tested at age 4, has this IQ within the next 5 years or even longer. So you can't really make this prediction. Between 4 and 6 years of age, there is again a low stability of around 0.7. So you might be able to do a prediction for the next 6 months, but not longer. And then from 7 years of age, you are able to predict intelligence values for the next 1 year, from 8 years on for the next 1 to 0.75 years, and then you see how it increases. And with 15 years of age, around this time, you really can make pretty long-term predictions. But before this, there's a lot of development going on. So that means that for young children, these test results, they are valuable. I don't want to be misunderstood. I'm a fan of intelligence tests, but the results have a very short half-life. There's another finding which is important when you want to evaluate the gifted child paradigm, because the gifted child paradigm is about IQ. And there is a hypothesis regarding IQ in high ability individuals, the ability differentiation hypothesis. So before explaining this, let me draw your attention to the structure of intelligence model. In psychometrics, we assume that intelligence is a hierarchy of different abilities. At the apex, at the highest level, there is the G factor, general intelligence. And below the G factor, there are more specific abilities. For example, like here in the CHC model, reasoning, knowledge, memory, speed, and so on. And the idea is that this G factors influences the more specific abilities. And due to this influence of G, we find positive correlations for the performance in different specific ability tests. For example, if you use a structure of intelligence test, or for example, the Wechsler test, and you assess the different indices or subtests, you usually find a positive correlation between subtest results. And it's assumed that this can be explained by the influence of general intelligence or the G factor. And the idea is that this influence is the same, regardless of age or ability level. And usually the average of all specific ability achievements is expressed as IQ, and IQ is then interpreted as a proxy for general intelligence. So it's pretty important if this assumption that the influence of G is constant over ability levels is true or not, because this differentiation hypothesis assumes that this is not the case. The main assumptions are depicted in this figure. I'll walk you through it. So on the x-axis, you see the level of G from low to high intelligence, and on the y-axis, the mean of all subtest scores. And it can be expected that with increasing intelligence, the mean in subtest score increases. So there is this positive correlation. And this funnel shows that how similar the achievement in the different subtests is. And you see that it's spreading out. So with increasing levels of G, the achievement in different subtests differs more and becomes more diverse. And that means that with increasing ability levels, you find lower correlations between subtests, that is, less influence of G. And the G factor, or the proxy for IQ, is therefore less informative because it cannot, when it influences test performance to a lesser amount, it doesn't explain as much anymore. So it's less informative and also has lower reliability. So, and this might indicate, we are not yet sure about it, that the specific abilities gain in importance for higher ability individuals. So where's the evidence for it? We conducted another review on studies investigating this ability differentiation hypothesis. And what you see here in this figure is the information of the G factor or the IQ over the score on the G factor or the IQ. And on the x-axis, the IQ ranges from 70 to 130. And you see that for most of these studies, the test information went down with increasing intelligence. And if you use these results to estimate the reliability of the IQ at these different ability levels, you find that it's pretty okay for a below average IQ of 70. For an IQ of 100, it's 0.79, which is for an intelligence test already not sufficient anymore, but it's really critical. At an IQ of 130, the reliability is only 0.38, which isn't acceptable at all anymore. So if you rely on IQs to assess giftedness in children, and if you take into account the evidence for the ability differentiation hypothesis, we can conclude that this diagnosis is very error-prone and has a lot has a very low reliability. It's not very good indicator. So what else? Ability profiles might be more informative then. And what might be a consequence of this differentiation in high ability individuals is what you see here. There are two profiles of two individuals. The green individual has a high intelligence, general intelligence, and the yellow individual has an average intelligence. And they were tested in 7 different subtests in an IQ test. And here you see the scores and how they are distributed around the mean. This is the solid line, and the dashed lines show the area around the mean within 1 standard deviation. And for the average ability profile, all scores are in this average ability range and very similar, so it's a flat profile. And for the green person who has a high intelligence, the profile is way more scattered. And this is what we also find in research. And there are studies, for example, from Lohmann or Lubinsky and others, showing that these ability profiles are more pronounced in high ability individuals. There are also high ability individuals with flat profiles, but the majority, around 60%, that's an estimation of David Lohmann, show these scattered profiles. And these profiles are also pretty stable in these individuals and have some predictive validity to predict later achievement. And they also, and I think that's very important, they correspond with interests, values, self-concepts, and domain choice. So in research, we always separate intelligence from personality, from skills, but in reality, it's all interconnected. And you see that this is the case, for example, when you have a look at findings from the study of mathematically precocious youth. They tested 13 years old precocious youth with tests for verbal, figural, and numerical abilities, and used the profiles from these testing age 13 to predict or explain the college major of these students 10 years later when they were 23, that's shown here, and their occupations at age 33. So these were all precocious, very intelligent youngsters, and their profile assessed at 13 pretty well predicted where they ended up studying or working later on. And here the x-axis shows the distribution of numerical thinking, the y-axis or the y-axis of verbal thinking, and then the little z-axis show the figural thinking. For example, students who were compared with the other precocious youth above average in all three ended up with a high probability studying science, physics, and so on. Students with a profile that has high figural and numerical abilities, but compared to the other high precocious youth, lower verbal skills, ended up in mathematics or computer science. Students who had low profiles in math and figural thinking, but high profiles in verbal thinking, ended up in humanities, education, psychology, and those with a below average profile in all three skills ended up studying business. But remember, yeah, that's a funny one, but remember they were all above average in all of these three scales. And this has been replicated by other researchers for student study programs at the Duke University. And it's pretty impressive because it shows that these domains, these profiles are important to understand where people are heading towards. Some more research findings. So we know intelligence develops and changes, but what influences this change? And here education is really important. Intelligence, in part, is an outcome of education, not only a predictor for educational success. And we know that the amount of education has a positive impact on intelligence, on average 3 to 5 IQ points per additional year of schooling, and also the quality of education, not only the quantity, the quality has a positive impact on the development of students' intelligence. So intelligence is important to understand talent development. It is one building block, but there are other factors that are important too. The specific abilities, especially if you take into account the findings of ability differentiation, are important. And they include, for example, spatial thinking, creativity, linguistic abilities, and the profiles should be not be overlooked. In addition, we know from other research studies that personality is very important, especially conscientiousness, self-concepts, and investment traits like need for cognition or growth mindset, motives and values. All of these are important when it comes to predicting talent development, to understanding why a person is able to achieve in a way he or she does. And skills, like things you learn during socialization and education, self-regulation, learning strategies, prior knowledge, and social competencies. So we know that potential cannot be reduced to intelligence, and within intelligence cannot be reduced to an IQ of 130 in terms of general intelligence. It's more complex. And besides abilities, there is personality and skills that come also into play. And their constellation is also very important to understand why a person is doing the things he or she does. For example, in the case of gifted underachievers, we have students with a high intelligence, but possibly a low achievement motivation or low self-regulatory capacities. Or we have students with high knowledge, but who don't believe in themselves. Or high creative students with low willingness to make an effort and low persistence. Or students with a great enjoyment of thinking, but little prior knowledge. And these are all constellations that are not favorable for talent development. So we need an expanded view on giftedness that includes that giftedness is dynamic, multidimensional, and also in part domain specific. And that's actually the talent development perspective. And together with this group, we designed a framework to capture all of these ideas. It's a very nice group. We are from 7 countries, and we are from giftedness research, but also from research on music or creativity or expertise or the arts. And we still meet on a regular basis. We've started this cooperation in 2018, and here you see a picture from 2021. We don't only meet online, but also in person. So the framework is meant to be descriptive. It's not to describe an ideal of development. There is no such thing, because this really is in the choice and freedom of each individual to decide where to invest and where not to invest. But this framework just describes talent development from potential to exceptional achievement. It's not all new. It includes major ideas from others and also the mega model. Understands talent development as a transformation of a person's potential for achievement into actual achievement in a domain, so not in general, but in a domain. And it acknowledges external factors, environment and support, but it's not included in the model, as you'll see soon. It's only focuses on person-related psychological constructs, and the environment is included by asking the person, how do you experience your environment? Do you feel supported? So it's through the psychological lens of the person. This is the model, and here talent development is a long-term process described in 3 columns. The first column shows developmental levels from aptitude to exceptional or transformational achievement. The second column describes processes of increasing specialization. So it starts broad, but you end up in a specific domain. And this process of specialization is informed by ability profiles that inform, again, domain choice. And if you then invest into a specific topic, you might eventually identify with it and gain expertise. And column 3 shows level-dependent predictors and indicators. So predictors are variables that explain talent development within one level, and the indicators describe what comprises behavioral indicators of talent within this level. And I'm going through these different levels step by step. So aptitude can be understood as a person's achievement-related developmental potential before any formal instruction in a domain. And it might be visible in the ease and speed of learning. Sometimes it's self-teaching, playful engagement, discovery, high energy, and an activity level. And it reflects individual differences in abilities, personality traits such as openness and motivation. And here it's about, in this level, it's about the individual constellation of ability, openness, and motivation, because these, this profile, here's an example for it, might show a natural fit with a specific domain and the demands in this domain. In this example, the profile of the child somehow has a better fit with the science domain than with the music domain. And if the environment the child lives in offers access to science and contents, the child has a chance to experience this fit and to experience that it's easy for him or her to deal with topics related to science. And this motivates the child to become more interested, to develop a personal interest in a field. So it's very important to have access to domains to find out about this natural fit. And if you don't have it, talent development is already hindered at this early stage. So then there is schooling, where society prescribes domains, and each child is confronted with math and languages and science. And this engagement in these predefined domains then allows for the acquisition of competencies. So competence is specific knowledge and skills, and these result from systematic learning and not self-teaching, but usually with support of good teachers in the broadest sense. So you need instruction, you need scaffolding, you need feedback, you need material to practice. And therefore, talent development at the competence level not only requires ability and openness and motivation, that's not sufficient anymore, but you need to have the ability to learn. And learning requires different things. For example, you need to have the self-concept, belief in your abilities, or being conscientious, or having the ability to practice deliberately. So this DP stands for deliberate practice. And also, the domain choice is important. So here, the fit of the profile with a domain still is decisive, because the better the fit, the more likely it is that a person becomes interested in the domain and is successful. So at this level, it also seems to be very important that students have the chance to find out his or her own thing. So what, regarding my abilities, my interests and values, my profile, what fits me? And then if you're lucky and you find a domain, further engagement and learning in this domain might also lead to more refined profiles. So you build up new knowledge, you develop your self-concept, you develop a more stable interest into the topic. And if you keep up this investment, you might reach expertise. So here a person overtly commits him or herself to a domain by a specific training or study. And this only happens for one domain. Competencies can be acquired in various domains, but expertise not. Here you have to really to specialize, and expertise is visible in constantly superior performance in the generation of good solutions to important problems in very specific knowledge. And if you gain expertise and if you want to use this knowledge, it's not only about learning anymore, as in the competence phase. Here, it's also important that you are able to intelligently use or apply the knowledge and skills that you have acquired. So this demands for self-regulation, planning, goal setting, metacognition, and also usually at this level you cooperate with others. If there are really complicated problems, you don't work alone on them. So you need social skills, you need to cooperate, to communicate. And then at the transformational achievement level, that means that you go beyond expertise, you really formulate new questions or a creative response, and this breaks boundaries. You really change the domain. In this figure, you see that this bubble got a different shape. So there is something going on that really changes the field, and it's beyond expertise. So this means that you really have to keep up your investment, even if you experience failures, and that for a long time. And this requires strength, psychological strength, persistence, and also charisma to convince others of your ideas. So this are the main ideas behind the model. And of course, in reality, things are much more complex, I know, and development does not happen in the straightforward process depicted here. But a model must simplify things and emphasize the main points, such as the point that psychosocial skills and personality become more important during talent development, or that for higher levels of achievement you need to specialize at one point, or that the predictors of development might change over time. Okay, so what are the practical implications of this perspective? First of all, for identification, this cannot be achieved with a one-time testing situation, as in the gifted child paradigm, but it becomes an ongoing process because what comprises potential changes over time, and by opportunities to learn, by support, and in response to the environment, potential can accelerate or can develop unfavorably. So there's some malleability, and you need constant testing. Potential can also be lost, and this is not included in the thinking of the gifted child paradigm. So for education, for example, this can be achieved by an ongoing formative assessment, not only testing or assessing students once or twice, but on a formative way, constantly, and for example, then documenting the results in a portfolio so that development really becomes visible. Also, identification, what you're looking for, might depend on the level. So what constitutes potential shifts to some extent during talent development. In the acquisition, in the aptitude phase level, you actually don't look for student characteristics to identify specific students, but you offer contact with domains, learning opportunities to find this natural fit between somebody's profile and the demands of the domain. But then later on, if you move to the competency level, it's important also to test students' learning strategies and general learning abilities. Later on, it's important what they acquired in terms of knowledge and skills. And at the expertise level, it's really about performing and solving complex problems. And it also requires a holistic view. It's not sufficient to look for cognitive factors alone, but this needs to be complemented with a personality and skill-related diagnostics and also their constellation. And it also requires different contexts because in part, potential is domain-specific. So depending on the context, a student might be able to show his or her potential. But if the constant is not very diverse and it's always the same, there is a limited chance to express what you have, what you know, what you're interested in. So it's really worth to also include extracurricular context, students' hobbies and spare time activities, or to design contexts in schools that are out of the regular curriculum, so to enable potential to be shown and discovered. And this actually prepares the next point. So identification should already include support elements, especially at the beginning. It's more about creating opportunities for development and observing if there is fit than to look for student variables. So first support, then find. And that's the other way around in the traditional approach. So usually you do the test first and then you support, but here it's more about front loading, about offering options, and especially students from minoritized backgrounds or students with talent in domains that is usually overlooked in school, they have a better chance to be recognized with this expanded approach. And to make this more concrete, I'd like to give you an example from a strategic research practice partnership that we conducted with schools in Germany, elementary schools. It's embedded in a federal project, Leistung macht Schule, LEMAS, and within this project, we were working on teachers' diagnostic competencies to identify students' potential in math and science in elementary school. And our first step was to work with the teachers to formulate a TED model for science and math in elementary school. So we scanned the literature, we reviewed research findings, but we also had discussions and workshops with the teachers, and we agreed upon that for abilities, there were a bunch of different abilities that are important, also personality characteristics and skills. And for these different factors, talent factors, we, in the second step, then developed diagnostic materials for the teachers that supports them during regular classrooms to identify these talent characteristics in their students. So we developed Lupe lessons. These are whole class lessons that can be integrated in the regular curriculum, and they focus on a very few talent characteristics. Usually they contain open tasks where students can diversify in strategies. And then teachers, they don't instruct, but rather observe their students working on these tasks. We have observational sheets, interview questions that help them to see the potential in their students. There are also questionnaires or interviews. And this material is also available in English. And we have a website, and you find the address here in the yellow box. The material is also accompanied by an e-learning series that lays the basics on talent development, teacher diagnostic abilities, and fostering options in school. This e-learning is in German only. And here is an example how this material can be used during the first 4 school years in elementary school. So you see that during one grade, one term, you can use 2 elements. For example, in the first term in grade 1, you do a Lupe interview on spontaneous focusing and attention, and a lesson on scientific thinking. And then in the second term, you do a screening on cognitive motivation and a lesson on creativity. So this is just one example how this material can be used. And by creating material and this process-oriented way to use it, the talent development perspective is implemented in the regular teaching. So identification is an ongoing process. It contains abilities, personality, and skills, and we have material that's specific for math, specific for science, or polyvalent for both. Here's an example. The decimal numbers from 1 to 50. This is for first graders. For the higher grades, we have numbers up to 150. And the students, they get these cardboard templates with left out windows, and they can play around with these cardboards to discover regularities and explore the decimal system. And we have some instructions, impulses to motivate the students to try to figure out some regularities. Here's an example for a divergent thinking lesson on creativity. There are different tasks. This is just an example. So we present students with a concept called leugli. There is no leugli in German, so this is indented, and they are allowed to respond to this. So what's a leugli? They can write a story, they can draw pictures, or they can do something with numbers. And here are just some examples from the students. And I translated a very original single answer. So one student said, leugli is a luminous climate radio. If you can't go outside, it creates a forest atmosphere with sounds like in the forest. And we had a lot of answers like this. So very nice. And for the teachers, this was really eye-opening because they usually did not pay a lot of attention to creativity in students. Here's an example for questionnaires and interviews. So we have for mathematical abilities, the spontaneous focusing on numerosity, relations, and patterns. The material has been developed together with researchers from these fields and people from didactics. It's evidence-based, and here you have these images you show to a student, and then you ask, what do you see? And some students really focus on numbers, others focus on the social situation. So it's very interesting what students tell you what they see. And those focusing spontaneously on numerosity, relations, and pattern might have a inclination towards math more than the others. There are questionnaires on academic self-concepts and interviews on interests. So we have picture cards for STEM fields, but also other school subjects or out-of-school activities, 16, and we present them either to the whole class or to individual students, and then there is a standardized interview following up. And so you can identify situational interests or stable interests in students, because many students have situational interests, but there are very few students in elementary schools already having stable trait-like interests, and it's interesting to distinguish between this. Okay, what are the implications for support? You have many different starting points. Besides cognitive skills and abilities, you can also focus on personality and skills. But in gifted education, the focus is often on abilities, which is also important. We have findings that the well-being of more intelligent elementary school students is more closely related to their achievement than that of less intelligent students. So for gifted students, achievement is important for well-being, but also important are being able to accept and use feedback, or to regulate feelings, persistence, the ability to learn from mistakes and setbacks, to assert yourself, to believe in yourself, to work together with others, to take risks, or to develop your own vision. And also potential can only show itself in specific domains, because it's not only general potential, it can be domain specific. And therefore, it's first of all important to find out about this by trying out a lot of different things. And if you find a strength, there are resources to focus on this. In school, education is frequently directed toward the areas that aren't working well, and less to those areas where a student has strength. So these strengths-based strategies are very important. And then domain-specific projects. In gifted education, I frequently see that promotion or fostering options are implemented in a way like this: Christmas trees. I like Christmas trees, so but the way it's provided to the schools is one training here and one enrichment there, and then there is another offer or opportunities, but there is no inner logic in what follows next. And from a talent development perspective, it makes a lot of sense to have this trajectory in your mind and carefully select options that match the talent of the student. So content-wise, but also the level. At the beginning, it's more about play, inspiration, enrichment programs. Then in the middle phase, it's about curricular or extracurricular programs that develop this basic knowledge and skills, competencies at an appropriate pace. And later on, it's more about independent projects, mentors, and authentic work in a domain. So here I collected some ideas that might be helpful to realize this in schools, because expertise and transformational achievement levels are rarely encountered in schools, but the foundations are already laid in school. So even during school, you can work on preparing students for talent development. So potential at the beginning needs to be stimulated. That means that it makes a lot of sense to introduce people to new things, really, that are new for them. Let them try out, stimulate and encourage people, encourage curiosity and enthusiasm. And here are some questions that might be helpful to do this. So what does a student respond to directly? What does he or she like to play with, or what's easy for him or her? And what doesn't he or she know yet? Competence is about learning, so enable learning of new things through appropriate instructions and guidance, and also strengthen learning prerequisites like learning strategies or self-confidence. Again, a couple of questions. How does a student proceed? What does she already know and can do? What does she dare to do? What is he interested in? And what does he deal with? And how does he deal with, for example, failure or challenges? All these are starting points for interventions. So to prepare the usage of knowledge and skills, it's interesting to strengthen, to find for first of all your inclination and strengths, to build up on them. Then also to strengthen social skills for cooperation and skills that promote the utilization of knowledge, like independence or responsibility for your own learning and coping skills. So I skip the questions. You can read them by yourself. And for transformational, it's about convincing others, communicating your ideas. So here it's important to support commitment, promote ego strength, resilience, promote the ability to see options, but also to create options for yourselves, and networking. So it's about creativity, dealing with risks and criticism, and communication skills. So to conclude, from a developmental perspective, talent development is a long-term process which is dynamically adapted and focuses on the whole person, and takes increasingly place in specific domains by processes of specialization. It goes way beyond the school context and includes the development of exceptional contribution as an option, not as a normative goal, but it's possible. Okay, so that's it. Thank you for your interest and your attention.
Yeah.
And now we have some time for questions, I think.
Yeah. This is where I stop the recording. Giving